Okay, so with our addition of ordinates, remember, now to match off the function, if you want to check it on the calculator, I have made a bit of an error. So the function itself is minus cos 2x plus 3 pi on 8 minus 2 cos x. So if you type in this function into Desmos or something like that, you will get the answers that we're looking for. But in terms of the process of adding the ordinates, what I did initially is, in green, wherever one of the functions is 0, it's really obvious then where your new graph goes through. So don't forget we're adding the y values. So the y value here, if we start from the left, is 0, which means if I add them together, I have to go through the blue function at the same point. The blue function is 0 at negative pi on 2, which means if we add them together, I have to go through the red function. Probably too many green dots there. So I'll just talk about. So I'm going to go through red function there. We can see halfway between negative pi on 4 and 0, so at about negative pi on 8, the red function is 0. So it means I have to go through the blue function at that point. If we scoot along to, again, probably, what's that going to be? 3 pi on 4, the red function is 0. So I've got to go through the blue function at that point because it's the y values added. The blue function is 0 at pi on 2. So I've got to go through the red function at that point. And then at whatever that is, 7 pi on 4, the red function is again 0. So I've got to go through the blue function at that point. So I know definitely I'm going through those points. Everything else is about. So in black there, what I decided to do is, well, let's add, almost adding the squares at some nice key points. So at negative pi, the blue function is at 2, and I've got to add 1.5 squares, I reckon, for the red function. So I'm going to move up about 1.5 points above the blue line. All right. So, and that's pretty much what I've done. I've gone for obvious ones initially. At negative 2, 0, or 0, negative 2, I should say, the blue function is negative 2. The red function is positive 1.5 squares. So I've moved up about 1.5 squares to be that point there. All right. At pi, if I scoot across to pi, you can see we're at 2. Again, I had to add about 1.5 squares, so I'm up to there. So I've just picked a few key ones. So I'll go over all the dots that I need. Actually, I'll do that in pink in a minute. And then the other ones I looked at is where the lines intersect. Where the red and the blue lines intersect, I must be twice that value. All right, so if I pick that point of intersection there between negative pi on 4 and negative pi on 2, I'm almost at negative 1. If I add the two values together, I will almost get negative 2. So I reckon probably that actual answer line is just a bit higher than that, isn't it? I'll add those 2 points together. Where else do we intersect? Between pi on 4 and pi on 2, we can see that, again, we're sort of a solid 3/4 of the way down. So I've got to add 2 of those together. So I'm going to be twice that distance. So maybe almost at the point of 1, or negative 1, I should say. So they're my 2 points of intersection. And then what I've done is, okay, let's just, any nice points that are on axes, I've tried to join them up. So when we come to doing our final answer, there's a few values just with ordinates that we can't be completely certain about. This turning point here, is it definitely down there? Or I've sort of, is that the turning point even? You know what I mean? So it's hard to identify some specific values. The dots that I've got there at the moment are pretty, you know, what colour were they? The black, no, the green ones are pretty definite. The black ones are pretty close. After that, it's a little bit, you can just get a feel. They're trig functions, so they've got to have a flowy effect. So look, you would never be asked, like for example, are we going up to there or do we go straight down to there? You know what I mean? You may not be able to pick it exactly. So we're just going to get a nice smooth curve going up through any dots. Yeah, so it won't be a perfect line. It looks a bit dodgy in around that section there. But again, if you actually sketch put the actual functions, the rules for those functions into your CAS, you'll get a good feel for what it genuinely looks like. But like, this is a very complicated question to try and do addition of ordinates. Would never be an exam style, but it's good practice. It is good practice to get a feel for what they look like.